Hey guys, this is CHEMPLIFIED, and in today's video we will talk about depression in freezing point. This will be our third colligative property which we are discussing. We have already discussed the other two, that is elevation in boiling point and relative lowering in vapor pressure. Today it is the third colligative property that we are going to discuss, that is depression in freezing point. So let's start. Before we continue in our video, what is freezing point? So freezing point is defined as the freezing point of a liquid is that temperature at which liquid and its solid state exist in equilibrium with each other. A temperature or any particular temperature at which liquid and solid state of the same substance exist in equilibrium with one another. The other definition is, it may also be defined as the temperature at which liquid and solid states of a substance have same vapor pressure. That is, liquid and solid state have same vapor pressure. In our concept which we are discussing, we can define freezing point as the temperature at which liquid solvent and solid solvent are in equilibrium. Liquid solvent and solid solvent are in equilibrium. Now, let's move. What is depression in freezing point? When a non-volatile solute, what is the meaning of non-volatile? Any liquid which do not want to evaporate or which do not evaporate easily is a non-volatile substance or liquid. So when a non-volatile solute is dissolved in a pure solvent, the vapor pressure of the solvent is lowered. When a non-volatile solute is dissolved in pure solvent, the vapor pressure of the solvent is lowered. We already know this because we have already studied relative lowering in vapor pressure, in which we have seen that when a non-volatile solute is dissolved in pure solvent, vapor pressure is lowered. Now, if T naught F is the freezing point of pure solvent and Tf is the freezing point of its solution, then Tf is less than Tf naught. That is, freezing point of solution is less than the freezing point of solvent. What does it mean? It means that solvent will freeze first. And solution will freeze second at low temperature. Than that of solvent. That means the freezing point of solution decreases to lower value, right? Now, the difference in the freezing point of pure solvent and the solution is called depression in freezing point, which is denoted by the term delta Tf. The value of delta Tf is del Tf is equal to freezing point of pure solvent, temperature at which pure solvent freeze, minus temperature at which solution freezes. Which means the solvent will freeze at higher temperature and the solution will freeze at lower temperature. Right? Now look at the graph. This particular line or curve shows the graph for frozen solvent. Vapor pressure is increasing, right? And this is the graph for liquid solvent. Now look at the graph for solution. The solution graph is this one. If you have watched the previous video, you know that this graph is similar to the previous one, that is elevation in boiling point. Now the liquid solvent converts to solid at this temperature, and this temperature is known as Tf naught, because the solvent is pure. So this is the temperature for freezing point of solvent, right? And this is the temperature at which solution of that solvent freezes, and this is known as Tf. And this is the difference This is the difference between the two temperatures denoted by del T. Del T and its value is given right here. Right? Now we will come to our formula. Just like, I repeat, just like elevation in boiling point, depression in freezing point is directly proportional to lowering in vapor pressure. Remember that. Just like elevation in boiling point, depression in freezing point is also directly proportional to relative lowering in vapor pressure. Now from that we find that del Tf is directly proportional to delta P, which is relative lowering in vapor pressure, which is in turn directly proportional to mole fraction. Now in place of this one, this mole fraction, we can write this value, because for dilute solution we can neglect the number of moles of solute, right? In total moles we can neglect the number of moles of solute, right? So this is the formula for Tf. Now in a similar manner we know that del Tb is also directly proportional to, this is what, elevation in boiling point is directly proportional to molality. Similarly in this case, depression in freezing point is also directly proportional to molality. Now here comes our formula, the formula which we use. Wait a minute. Now we can write it as del Tf is equal to Kf multiplied by molality, right? We can write it as Kf multiplied by molality. Now what is Kf? Kf is molar depression constant. Kf is molar depression constant. Now what is molality? This is where our formula changes. Kf multiplied with number of moles of solute, that is N1 upon mass of solvent in kg, right? This is the formula for molality. Now just like depression in freezing point, the formula changes as follows. Del Tf is equal to, now what is the formula for number of moles? Number of moles is mass upon molar mass. So we can write it as W1 for weight of solute. Wait a second. Kf multiplied with number of moles is written as mass of solute upon molar mass of solute multiplied with 1 upon mass of solvent in kg. Now in general we found that in our questions the weight is in grams, right? The weight of solvent is given in grams. So you have to convert that weight into kilogram. So to convert it you have to divide it by 1000. Now you will get the final formula. Del Tf is equal to Kf multiplied with weight of solute multiplied with 1000 upon molar mass of solute multiplied with weight of solvent in gram, right? Now this is your formula to calculate depression in freezing point. This is the general formula that is used for calculating for solving numericals. All right, so this was your depression in freezing point. Now why this one is also a colligative property? Why this one is colligative property? Because it depends on number of moles of solute. And what are colligative properties? Colligative properties are those physical properties of the solution which depend upon the relative number of solute particles. Now we know that del Tf is directly proportional to relative lowering in vapor pressure, which in turn is directly proportional to mole fraction. Mole fraction is nothing but number of particles. Right? Mole fraction is nothing but number of particles. That's why elevation in boiling point as well as relative lowering in vapor pressure, since both depend on number of particles of solute, they are colligative properties. Right? So this was your video for depression in freezing point. Thank you very much for watching.